Figure 7.12, Testing Character Arrays as Strings. In earlier examples, we introduced to you the C++ standard library string class, and we used it to store strings of information. We also used the getLine function from the string header file to allow you to read in an entire line of text and store it in a string variable. Well, before the string class existed in C++, C++ strings were actually processed as C strings, and basically what that meant is that the strings were placed into character arrays in memory. And so what we are doing here is just showing you that in C++, and I want to use this as an opportunity to talk a little bit about why you should try to use the C++ string class whenever you possibly can. So in main in this program, we have a character array called string1 with 20 character elements, and we have a second character array called string2, and it's going to be initialized with the string literal. And you see here in our comment that it says it reserves 15 characters. Well, if you count with me here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, you see that there's 14 characters in the literal, but really there are 15 characters because at the end of every string underneath the hood is a \0 null character escape sequence. And so in reality, line 11 is actually going to reserve an extra character position for that null character. And that's how C and C++ figure out where a string in memory ends. Now in this program, we're going to have you enter a string, and we're going to show you that you can read in strings and process them. So let's run the program first, and then we'll take a look at the rest of our source code here. You can see we're explicitly asking you to enter the string hello there, so let's go ahead and do that. And when I read it in, you see that the string is hello. So let's talk a little bit about that here. So the first thing we did was prompt you to enter the string hello there, and then we said read in into the character array string1. And what happens is, by default in the input, the space characters are considered to be delimiter characters. So when you say to read using cin into a character array or even into a string variable, which you can do as well, in both cases, as soon as the cin object encounters a space in the input stream or a tab or a new line character, that's an indication that it's hit the end of quote-unquote a token, and that token is then returned to the program, and in our case the first token is the word hello. So if I stop there for a moment, this line 15 read in only the word hello, and the remainder of what I had typed is still sitting there in the input stream waiting to be read. The next thing we did at line 18 is we displayed the values of string 1 and of string 2. String 2 you saw was initialized with string literal. So you see here string 1 just had the word hello, and string 2 contains the words string literal. Then, to show you that you can process a string of characters one character at a time, at lines 23 and 24 we have a little for loop that starts counting from position 0 in the character array, and as long as the current character that we're looking at is not equal to the null character, we're going to output that character followed by a space and increment the counter. So this is a little bit different kind of condition from what we've seen in our prior for loops. In this case, we're checking to see if the current character is not equal to the null character, which is the indication of where the end of the string is in memory. And the reason that's important is that our string array has 20 characters in it, but what actually got stored is just the word string, which is 6 characters plus the terminating null character. So we don't want to go all the way to the end of the array. We only want to go to the end of what's stored in the array, which is the word string at the moment. So here at lines 23 and 24, one character at a time, we iterate through the array of characters, and you can see that we were able to output the word hello with spaces between each character. Then, to show you that the rest of what I had typed originally back up here is still in the input stream, we read in to string 1 again. That reads whatever happens to be sitting in the input stream, and I then output that here at line 27, and you can see that the word there is read in next. The space that was between hello and there was actually read in and thrown away, because the way cin works is it automatically ignores the white space between tokens. On the other hand, if you use cin's member function get, that will read every individual character one at a time that you type in the input stream. And we showed you that when we demonstrated entering letter grades and when we introduced the switch statement in the previous lessons. So again, the main purpose of showing you this example is just to show you some old style C-like string processing. It's not completely C-like in that we're using the C++ input and output capabilities, but the idea is to show you that character arrays can indeed store strings. Now the problem with what we've done here is that a character array is an array, and in C++ arrays do not have any bounds checking. So let me run this program one more time and show you that I can type a really long string here, and when I press enter, it's perfectly happy to read that whole thing in and store it even in my 20 character array, which is definitely not long enough to store all of these characters. So what happened here is I literally just wrote in memory not only into my character array string 1, but well past that in memory, which could have potentially overwritten other variables in my program. In this case, it happens to have worked, unfortunately, correctly. And this is something that you have to watch out for in C++. This is what you might call a buffer overrun, the buffer being string 1 array with 20 characters in it. So when you read data into arrays, you need to make sure that you stay within the bounds of the arrays. And this is the type of problem that causes a lot of the security issues that we run into nowadays on various operating systems. Buffer overrun errors or overflow errors are commonly referenced when you're reading about various viruses and bugs that people exploit to take over systems around the world. So in general, you want to try to avoid doing what I just did, where I read in as many characters as I did and simply went past the end of the array in memory. And one way to do that is by, anytime you need to process strings, working with the string class, which is written in a manner to prevent something like that from happening.